Okay, on to Gareth John, who is a lead architect at Q Associates, someone that we've partnered with for many years now, who we're talking about the challenge of achieving true mobility for data center workloads. So over to you, Gareth. Thank you.
Thanks, Mehmet. Good afternoon, everyone. I'm Gareth John, lead architect and technologist for hybrid cloud and infrastructure services at Q Associates. Thank you for joining us to discuss the challenges that we see with our customers and what they're facing when it comes to achieving workload mobility within the data center. This includes those applications that are on-prem and those that have been or are going to be moved to cloud. As we're quite short of time today, I'll be running through these slides fairly quickly, but I hope this will give you a taste of the types of discussions we're having with our customers. And if you'd like to go into any more depth in any of these areas, then please contact us and we can arrange a session where we can continue the conversation. The contact details will be on the final slide. By way of a brief introduction to Q Associates, for those that don't already know us, we are an independent supplier of IT solutions that span on-prem data centers and clouds. The key word here is independent. We act on behalf of our customers and not the technology vendors or cloud providers. We started in exactly the same place as you, in the on-prem data center. And now, because of the demands of the modern data center, we also provide services and solutions that utilize the public cloud, including readiness, transition, and optimization. We have a mixture of commercial and public sector customers and have been recognized as a top 10 supplier to UK universities. We've had a relationship with ucisa for over 20 years. And in that time, we've consulted, supplied, transacted with hundreds of universities and research establishments. The purpose of this presentation is to provide you with insights into the topical conversations we're having with our customer base, with the hope that these will be relevant to you also. So let's start off by talking about workload mobility and why it's important. Most people we talk to have the desire to move at least some workloads from on-prem to the public cloud. The motivation behind this is not usually to do with cost reduction, but we'll look at this a bit later in the presentation. The more common motives, however, are to do with agility, innovation, and resilience. In terms of agility, the cloud provides near infinite scalability with always available resources. And as long as workloads aren't turned on 24/7, then the cloud economics of only paying for what you use can be made to work in your favor. And of course, the cloud has an abundance of unusual resources that you can essentially rent for the period of time that you require them. An example of this could be that you could utilize cloud GPU servers when you need them and only pay for them when you use them, rather than having to purchase your own expensive infrastructure that you then need to try and maintain with high utilization. The cloud offers a wealth of services that cloud-based applications can utilize. As an example, one of your applications might require text-to-speech functionality, and you can tap into the cloud's capabilities to achieve this. You can also improve resilience by designing modern cloud-native applications that can inherently take advantage of resilient constructs like availability zones. Now, if you're building new applications, then they can be designed to be cloud native and will immediately be able to exploit these cloud capabilities. If you're transitioning legacy workloads, however, you should really ask whether the workloads will benefit from these cloud capabilities. And if they won't, then it proffers the question as to whether these workloads should in fact be moved at all. The challenge with this picture is that workloads that are based on virtual machines aren't very portable between on-prem and cloud. They require a transition, unless of course you're moving to something like VMware Cloud, which maintains the same format as on-prem vSphere environments. You should also strive to have workload mobility between different clouds so that you can utilize the best and most cost-effective services. Let's say an application is in Azure and it's utilizing Microsoft's cognitive services to provide a text-to-speech function. Now let's say that you realize that you could get a better result if you used Amazon's Poly text-to-speech service. In this scenario, it would be beneficial if you could simply move your application from Azure to AWS and start tapping into Amazon Poly for your text-to-speech requirements. A multi-cloud strategy not only increases resilience, but is also provides better choice and therefore increases competitiveness. A similar challenge here though. If workloads are based on virtual machines, they are not very portable between clouds. Let's take a quick look at containerization and how this can solve some of these challenges. First, let's take a look at a virtual machine that starts its life on-prem. It has a hypervisor that allows the virtual machine to interact with the physical server resources like CPU and memory, and it has a full operating system installation. The files that make up the virtual machine are in a format that the hypervisor understands. Now you can also get VMs on AWS and Azure, and they can have the same full operating system installed. However, the hypervisor technology in each of the cloud locations is different from the on-prem hypervisor. So if you try and move a VM from on-prem to a cloud or from one cloud to another, then there's incompatibility. The only way you can move a VM to and from on-prem and between different clouds is via transition. We need another layer of abstraction to enable workload mobility, and containerization provides this. A runtime environment such as Docker is installed on top of the operating system of a virtual machine. This allows the containers that run above this to share many of the resources that reside in the operating system. This makes them much more lightweight than VMs. Containers increase agility as they can be started up or torn down in a matter of seconds. Compare that to the minutes it takes to boot a VM. Containerization also drives better utilization of resources. In terms of mobility, a VM with a consistent operating system and consistent runtime can be created either on-prem or within a choice of clouds. This allows containers to be very easily moved between on-prem and disparate cloud environments. Now, this is all very well for stateless containers that don't need to remember their state. An example of a stateless container could be something like an online search. The output is dependent on the search criteria, but it doesn't need to remember anything to perform another search because the new search output will be dependent on new and independent search criteria. The challenge around containers becomes when there is a need for statefulness, when a containerized app needs to remember information. An example of this could be a shopping cart application, which needs to remember the items that are in the cart, even if the application needs to be restarted. Stateful containers rely on storing data, and data has gravity. The goal for stateful containers is to present feature-rich and efficient storage that integrates with container orchestrators such as Kubernetes. It is also important that this storage can provide data protection attributes such as snapshots and clones. The key is being able to present persistent storage and data protection features to containerized environments no matter where they reside in a consistent manner. This will typically mean that you need a storage operating system that can just as easily be deployed in multiple clouds as it can be on-prem. Finally, the integrated persistent storage that is presented to any of these locations needs to be able to replicate data between sites. And because of the weight of data, this is the only way to achieve true workload mobility, especially when the workloads necessarily include stateful containers. We'll take a quick look now at how containerization fits into cloud transition strategies. I imagine you've all heard of the 7 R's of cloud transition. Here we describe these options in the context of workload mobility. The first strategy is replace. This is when an application is replaced typically by a SaaS offering. For example, replacing on-prem Exchange or SharePoint with Microsoft 365. Although there is a cost associated with this transition, you can offload all hardware, software, and application maintenance tasks to the provider and gain access to the latest features of the application without having to upgrade. Mobility isn't really applicable to this kind of deployment because you're simply consuming the service that is being provided. But what about the other applications that you have that aren't covered by SaaS offerings? Well, the first two things you can do is retain or retire them. Retaining an application won't have any transition cost because it is just remaining where it is. But do note that the infrastructure that these on-prem applications reside on can still be optimized to save money. Of course, retiring an application will only normally be done if it is obsolete or has already been replaced by something else. The remaining 4 strategies, rehost, replatform, refactor, and rebuild, apply to workloads that you really intend to move to cloud. Rehost, otherwise known as lift and shift, is by far the least complex and therefore the least expensive of the remaining options. It involves running very similar VMs to the ones that are running on-prem, but in a cloud provider's IaaS environment. There aren't really any gains or losses in workload mobility when compared to retaining applications. The same sort of transition would need to be carried out again if you wanted to move the application at a later date. Replatforming starts to change the application structure by replacing some of the legacy VMs with cloud native services. Because the complexity in the transition increases, so does the cost. And because we're now using services that are only available in one particular cloud, workload mobility is decreased. Refactoring takes this to the next level and is generally considered to be the most complex and expensive of all the transition strategies. Legacy applications must be completely redesigned to use native cloud services, which is also the reason that this outcome provides the least workload mobility out of all of these transitions. Rebuilding applications using containers also requires the application to be redesigned, and so regarding transition of legacy applications, this is also complex and expensive. However, this approach will provide the best workload mobility. When we talk to our customers, generally the goal when building new apps is to design them so that they're cloud native, so following the refactor or rebuild methodologies. However, these strategies are seen to be too complex and costly for the transition of legacy applications, and so rehosting is the favoured approach for most of these workloads. It should be noted that in terms of workload mobility, neither VMs or native cloud services are very portable between clouds, but containers are. Next, we take a look at the cost of the simplest and least expensive transition strategy, the rehosting or lift and shift. The figures within this example migration were taken from a Gartner blog. Whilst these figures don't include all factors such as growth and potential unforeseen projects, they do serve well to illustrate the cost of transitioning legacy applications to the cloud. Just to iterate, these are not my figures but Gartner's, or at least they're the figures that the analyst used in his blog. And they are for the least expensive migration strategy, rehosting. In this TCO graph, the y-axis shows the cost per quarter of the various elements. The x-axis is a 3-year timeline that is broken down into years and quarters. The elements being plotted are the quarterly costs of on-prem infrastructure, migration investments, and cloud costs over this period. The first 3 quarters show a constant spend on on-prem infrastructure. This is the baseline cost, what would need to be spent per quarter if there were no cloud transition. As well as on-prem costs, we see a significant increase in migration investment, and cloud costs also increase as a result of workloads being moved to the cloud. Migration continues in the 4th quarter of the first year, and now we see on-prem costs reduce as workloads that have already been migrated can be turned off excuse me, in the on-prem environment, albeit with a noticeable lag. Over the next period, in spite of migration investments reducing in size, workloads continue to be migrated to the cloud, and so we see cloud costs rising and on-prem costs falling. Now that all the workloads have been transitioned, we start to optimize the cloud environment using things like right-sizing, schedules, and reserved instances. The result being a significant reduction in cloud costs. At this point, a new baseline is reached, which shows the constant ongoing cost of running the workloads in the cloud. Now, the first thing to notice is that without optimization, cloud costs are considerably more expensive than on-prem costs to run the same workloads. However, optimization can reduce cloud costs dramatically. These figures show that the final cost to run the workloads in the cloud are significantly lower than running them on-prem, but it doesn't factor in the time and the effort it takes to maintain these optimizations and prevent data sprawl over time. There are tools available that can help with and even automate some of this optimization, but these will obviously eat into the potential savings of moving things to cloud. Nevertheless, this reduction in quarterly costs is the headline that most cloud providers will publicize. And whilst these figures are very useful, they don't tell a full story. Now let's look at the return on investment projections for these very same figures that were provided by Gartner. The following ROI graph will show cumulative values for each year, such that year one costs will be the sum of that year's quarterly costs in all three categories: on-prem, migration, and cloud. First of all, let's plot the on-prem costs that would be incurred if no cloud transition was carried out. This is our do nothing baseline, and as we can see, the straight line indicates a steady yearly or quarterly cost. The steeper the line, the more expensive the quarterly costs would be. If we now plot the costs associated with the example migration, you can see that the line in year one is the cumulative costs that were charted on the previous graph for the first 4 quarters, including on-prem, migration, and cloud costs. If we continue and extrapolate the figures once the new steady state cloud costs come into effect in year 3, then we can see that the shallower gradient indicates less year-on-year cost when compared to the baseline of on-prem costs. From this point, the new model starts to repay the debt incurred during the migration. But if we consider that on-prem infrastructure could also be optimized, then it could well be over a decade until the project realizes a positive return on investment. And don't forget, this is the simplest and cheapest of all the transition strategies that we discussed earlier. The reason for this lengthy ROI is the mountain of technical debt that is built up during the transition, and it's a transition to a non-optimal state, considering that cloud native applications are the ultimate goal and not just simply lifting and shifting VMs to the cloud.
Just a couple of minutes, Gareth, sorry.
Okay, with that in mind, many of our customers are concluding that the cost of lift and shift at least most of their legacy applications to the cloud is not worth the investment required to get them there. Instead, they're concentrating on either replacing applications with SaaS offerings or building new cloud native containerized applications that will eventually enable legacy applications to be retired. With this more cautious and direct to end goal strategy, there may still be some residual on-prem applications in the future, but many of them will have been replaced or retired within the previously discussed ROI term. And those workloads that have been moved to the cloud will be cloud native, efficient, and portable. So in summary, efficient and optimized on-prem infrastructure is important today and will continue to be important in the future as organizations strive to modernize their applications and utilize the public cloud. Rushing into a lift and shift cloud transition strategy could build up a significant amount of technical debt whilst resulting in an outcome that's only halfway to the ultimate goal. Where possible, new applications should be containerized so that they can be developed and deployed anywhere and then relocated to provide the best business value. Start with on-prem infrastructure that will not only allow you to continue to serve legacy VM-based applications, but will also allow you to develop new containerized applications by providing feature-rich and integrated storage. This infrastructure should be able to present persistent storage to containerized environments and should also be deployable across clouds, so that consistency is achieved across the future estate. This is the true path to data mobility. Q Associates realizes that all customers and their requirements are different. We're equally comfortable whether the decision is to retain applications on-prem or to move them to the cloud. In reality, we expect there to be a mixture of all of the application designs that we have been discussing today. We work collaboratively with our customers to ensure that they avoid unnecessary technical debt and drive the outcomes that are best for them, not for the technology vendors or the cloud providers. Q Associates therefore provide a full range of solutions and services that include assessments, design, implementation, support and management of both on-prem and cloud environments. We design solutions that enable our customers to continue to run VM-based workloads while simultaneously creating new containerized applications. We believe that customers should have the choice to run workloads wherever they will provide the best business value and have the choice to change those locations at any time in the future. Optimization is paramount in the cloud, but it's also important for on-prem infrastructure. And this is why we offer optimization products and services that cover all locations that customers may deploy their workloads. And with that, I shall finally take a breath. And if there is time, I'll welcome any questions that there may be.
Thank you very much, Gareth. Any questions for Gareth?
Hi, Gareth. Can I ask a quick question? It's Andy Powell here from JISC. I mentioned in the chat, I mean, you talked a lot about agility as being one of the drivers for people going to cloud. And I said in the chat, I suspect that in the future, considerations like environmental footprint and security may become almost as big drivers. And I just wondered if those kinds of issues are coming up in the conversations that you're having with universities.
Yeah, definitely the environmental side of things, most definitely. I think, you know, if you have a look around the internet, there are the odd, there's the odd opinion that says it's not greener to go to cloud, but I think the majority of people agree that it probably is, with the efficiencies of and the economies of scale that those kind of data centers can provide. So yeah, I think you know, green data centers, that is very much being talked about, certainly when moving to cloud. I think security, as probably covered from a previous talk, is something. I think people believe that the cloud possibly could become more secure than on-prem, but it involves re-educating how you manage that security and how you design security into the application at every single step. And I think, you know, when you do that and design an application with security in mind, then yeah, most definitely the you know, a cloud deployment of a modernized application could improve security as well.
Perfect. Okay, thank you. It's helpful.
Thank you for your question, Andy, and Gareth, thank you for your presentation. If you do have any more questions for Gareth or Q Associates, please do get in contact with them. And Gareth, I'm sure, will put his email address in the chat. Thank you. Thanks, Gareth.
Okay, thanks, Mehmet.
Thank you.